Okay, let's dive right into this explainer. Look, if you've been tracking the AI space lately, you know the industry's absolute obsession has been scale. Just, adding more GPUs, building these massive clusters, and cranking up the compute. But today, we're unpacking a framework that argues we might literally be looking at the bottleneck all wrong. We're examining the core philosophy behind a project called Codatta. According to the source material we're analyzing, the defining factor for the next generation of artificial intelligence isn't necessarily just more compute, it's the underlying fuel. We're going to break down how they define this new frontier of intelligence, and honestly, more importantly, what they argue the current ecosystem is fundamentally lacking. Which brings up what is basically a multi-billion-dollar question in the industry right now. Why do AI models actually fail? I mean, we push these advanced systems into edge cases, we try to integrate them into complex daily workflows, and yet they still hallucinate. They lose the plot, or they just simply hit a performance wall. Think about the standard industry reflex when a model doesn't behave exactly as intended. Historically, the knee-jerk reaction has been to just throw a massive mountain of extra compute at the problem and hope sheer brute force smooths out the edges. For years, the dominant narrative has been pretty straightforward. Build it bigger, right? If a model fails, well, it must be because it doesn't have enough parameters. It's almost become a running joke in the space. Just add another trillion parameters to the training run and call it a day. But Codatta's framework pivots entirely away from this parameter obsession. Their thesis argues that models hit these walls not because of their size, but because they lack the right data. It's not a problem with the engine, it's a problem with the fuel. In their view, the bottleneck preventing models from taking that next leap forward isn't a lack of computing power, but rather the sheer quality and specificity of the data they're actually trained on. So, if the problem is a lack of the right data, how does the source material actually define what the right data is? They use a very specific term here: frontier data. The idea is that the easily accessible, generic web data, the stuff that currently trains most foundation models, it's largely been exhausted. We've tapped it out. To push artificial intelligence beyond its current limitations, the argument is that we need highly specific, critical information that hasn't yet been mapped or fed into these systems. Frontier data in this context is positioned as the absolute missing ingredient. It's what's required to cross the boundary of what AI is currently capable of doing, moving way past that plateau we're starting to see in generic model performance. And when you look at where this proposed frontier data actually lives, you instantly start to see why generic web scraping falls short. We're talking about highly complex, specialized domains: robotics, healthcare, finance, culture. Just think about the stakes here for a second. A hallucination in a standard consumer chatbot is usually just a funny meme. But a hallucination in a medical diagnostic tool or an algorithmic trading system, that is a catastrophe. These environments require absolute precision and a deep, nuanced understanding that you simply can't scrape from generic forums or public websites. The source material highlights these four specific areas as the primary domains that desperately require this next-level data infrastructure. To address this, Codatta outlines a totally new framework for how data should be sourced and valued. And it's built around three specific traits. First, they argue this data must be proprietary, meaning it's exclusive and purposefully generated, not just passively collected from the open web. Second, it has to be exceptionally high quality, which completely aligns with the strict demands of those high-stakes fields like finance or healthcare we were just talking about. And third, and this is perhaps the most interesting part from an economic standpoint, they propose it should be royalty-backed. This introduces a distinct financial mechanism right into the data pipeline. The goal is to ensure that the actual originators of this high-fidelity information are recognized and financially compensated for their input. There's this one specific line in their documentation that really captures their overarching philosophy. These aren't just data sets, they're launch pads for the next frontier of AI models. It's a really interesting semantic shift. Traditionally, a dataset is viewed as something static, right? Like a giant archive of text or numbers just sitting passively on a server somewhere. But by using the metaphor of a launchpad, Codatta is framing their approach to data as active infrastructure. The source is arguing that this specific high-quality data isn't merely a resource to be consumed, but rather the foundational catalyst required to propel AI systems into entirely new tiers of reliability and capability. Which ultimately brings us to a huge proposed shift in methodology. For a long time, the industry status quo has just been passive extraction, basically vacuuming up everything available on the internet, scraping data from users to train massive models without much of a second thought. Codatta's framework outlines a sharp pivot away from that old model, moving instead toward a system built actively with willing contributors. By tying this back to that royalty-backed concept we touched on earlier, the source outlines an alternative ecosystem. one that attempts to completely redefine the historical relationship between the people who generate valuable information and the machine learning models that are trained on it. And that leaves us with an incredibly compelling question to consider as this whole industry continues to evolve. In the next frontier of AI, will your data be scraped, or will you be a contributor? Look, the consensus is that more advanced models are absolutely inevitable, but the source material we've broken down today makes a very strong case that the defining factor of this next era won't just be parameter counts or massive compute clusters. It will be data provenance. As these systems expand deeper into robotics, medicine, and beyond, it's definitely worth thinking about how the fuel powering them is actually sourced. Thanks for joining me on this explainer, and I'll catch you next time.